Well, that's a quick shot across the bow.
I like. I'm going to grab one other thing. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 259, Twin T 3D and driving to a T. This week in the news, we have two bits of Hackaday news. First of all, our home automation contest started this week. This is Home Sweet Home Automation. If you have anything that's home automation hack related, you should enter it in this contest. As usual, this is sponsored by DigiKey and has $150 DigiKey gift certificates. And we're just between you and me and everybody out there listening, I'm trying to sneak in some extra prizes for the honorable mentions, and we'll see if I can get that to work. Yeah, so home automation can be anything. Could be really simple, could be really fancy, could be, my home automation setup here is basically an orange Pi that's been running for 7 years now. The thing cost me $7. It's unbelievable. Sitting there in the corner, listening to Wi-Fi and pulling down everything over MQTT. And that means I just put the things on and off the system kind of ad hoc at will. And I think mine qualifies for the Rube Goldberg honorable mention category.
Well, that would actually be a good contest, is just the actual Rube Goldberg home automation. So, I loved those. The sun rises, waking up cat A who swats at mouse B. We can really have some fun with that.
But then other people take it to the extreme and do huge integrated systems. Those are awesome too, of course. Man, my favorite we've seen recently was this one wood loading robot. It was a robot that's kind of built into this guy's basement that picks up cut pieces of wood and puts them in his furnace.
Wow.
And it is so janky, but so fantastic. But it's all like limit switches and pieces of tubing and rollers, and it works phenomenally well. And it also has a boiler temperature sensor, so it stokes more wood in the fire when it gets cold, when the fire gets cold. It's actually really an awesome piece of automation, but you have to watch the video because it's just such a janky cobbled together system. It's really beautiful.
But there's so much that you could do with automation when you had only mechanics to do it, right? So just a steam engine regulator is a thing of beauty, right?
Yeah,
or
true.
If you've ever taken apart a pinball machine back from the old days and it's all, clutches and solenoids, and it's just amazing. Cams and timing motors, but now it's so easy. That used to be a horrible thing to say, well, I'm going to do this when the temperature goes below this for 30 seconds, and now it's 8 pieces of code on an Arduino. So
yeah, we've got it so good. Like other honorable mention categories are data logging ones, either displaying the data or just, massive array of sensors and data hoarding. We would love to see how you manage that. And of course, hacking things into your home automation system. So kind of a retrofit category. Anyway, anything you do, if it helps you out in your home, it's fair game for Home Sweet Home Automation.
So what are we going to do about office automation? I'm sure there's people out there doing fun things in their labs and their offices.
Ooh, I think that counts.
I hope so.
I think your lab is your home, or your second home, or your extended home. Yeah, I think that's good. I think we'll have to count that. Unofficial rule change. Thanks, Al.
You're welcome.
And the other bit of news is Hackaday Europe call for participation is ended. We had a couple people saying that they wanted to get their presentation proposal together, but wanted another few days. So we're going to give you a week. And the good news is February has 29 days this year. So leap year. So we're going to extend it for a full week out to February 29th. And then we're going to start looking at them in earnest. If you are able to make it to Berlin April 12th through 14th, you absolutely should. And if you want to give us a talk, you absolutely should. Here's your last week to send in a proposal. And if you don't make it, we, of course, will have lightning talks on that Sunday. So you've got a 5-minute slot with your name on it already. But if you've got more to say, head on over to the form that you'll find linked in. Head on over to the form that you'll find linked into our announcement, and links will be in the show notes.
Well, I would love to go to Berlin, but I don't think it's in the cards for me. So
it's a long way to travel. And that's actually half the reason we do it in Europe, too, because probably fully half of our listeners and half of our readers are here in Europe, more or less, and maybe a little less than half, but pretty close to half. And so it only seems fair to have an event on this continent too, so that not everybody has to fly internationally.
This is a journey into sound.
What's that sound?
What's that sound?
And so with that, let's head on off to What's That Sound? I got a cool one for you this week.
Oh boy. You know how I love What's That Sound?
All of my victims love it. I mean, participants.
Say it's the Jupiter 2 from Lost in Space taking off. I don't know. I'm on a spaceship kick.
That's good. That's good. Yeah, the clue to the sound is what it sounds like it's doing.
Spinning.
Yeah, yeah, right? It does a little. Well, if you listeners out there have an idea what this is, head on over to hackaday.com/podcast. I will have a form for you to fill out with your handle and your best guess. And if you get it right, we'll put you in the drawing for a Hackaday t-shirt next week. All right, well, off to hacks. I'd like to lead off this week with serial robot builder Aid Musa. This time he's building a compact cycloidal drive lived inside this custom brushless motor. And this is really neat. Aid's made a couple robots, actually, and fully detailed them on Hackaday.io. You should really check that out, or check out his personal website now. Really fantastic engineering. A lot of 3D printing, a lot of custom stuff, but he's working on kind of big dog style walking robots, you know, the four-legged quadrupeds with huge brushless motors turned servos in all of the joints. And that's kind of been what I've liked seeing most about his projects develop, is his working on getting these motors and gearboxes done on the cheap, you know, kind of DIY friendly. And this is his latest motor. It's really neat because he's moving away from the off-the-shelf brushless outrunner motors that, you know, he's been using before. And here he's actually building his own motor. And the reason he's doing that is so that he can put the gearing, it's got a low gear ratio so that it can be back driven, but it's like 8-to-1, I think. It's gotten enough so that it's got high torque, but it's low enough and back drivable so that he can use it for force feedback on the walking dog's legs. I digress. The really cool thing here is that he's building his own motor to get this gear mechanism, and in this case a cycloidal, into the motor itself, which makes the whole motor pancake unit a lot thinner than it would be otherwise. So what's cool here is that he goes through building his own motor. And so building your own motor isn't that hard. In this case, he buys a stator core and then just wraps his coils around it himself, and then you buy a whole bunch of strong rare earth magnets, and he 3D prints the rotor part of it and adheres the magnets to that in his first version of it just to test it out, and then builds this custom cycloidal gear drive that then fits inside it all. He then takes these 3D models and gets them machined out of metal, which is of course stronger, and etc. He tests it. It works fantastically well. It works just as well as the motor he bought off the shelf, but the whole stack up is of course thinner because the gearing is inside the motor. And that's really cool. The worst thing happens, which is that so the bell he's got CNC milled out of metal, but then there are parts that are still 3D printed in there. And when he's doing some weight testing, it actually gets hot enough that some of the plastic melts. The thing gets asymmetric and doesn't work so well anymore. And at the end of the project, he actually kind of says he was going to give up on this one anyway because it does have a little bit too much backlash in the gear design. He thinks he can get that out with better tolerance, but who knows? But all in all, it's actually significantly more expensive. And this is where, like, the off the shelf solution, of course, always wins, right? Plus 6 hours of wrapping stator wire. But the other part of the off the shelf solution is that it's just cheaper to buy the motors. And his motor has kind of exactly the same performance as the one he was modeling it after, which is on one side a really awesome sign, right? Like, that's the sign that he's building the motor right. He's building the motor as well as like a commercial company can do it. But at the same time, they sell these things for like 100 and something bucks, and he estimates his cost at, kind of around 400 for the one.
Not counting his time. Yeah, not even counting his time.
Yeah. So ow. But don't be discouraged. He is, of course, going to be back making more robots and more motors and more gearboxes and all of that. And it's really, really cool.
I'm always so amazed, though, that we are at a time where just somebody in their shop can build something like this, and it kind of goes back to what I was saying earlier. There's all these sophisticated automation techniques that used cams and timing motors and, all these things. And back then that was hard. It makes you wonder if we'd had 3D printers show up before microcontrollers in some weird alternate universe, how much more people would have done with the mechanical stuff. I'm not much of a mechanical guy. I'm not a mechanical engineer. I've worked with a lot of mechanical engineers, and I think the problem is what you know. So I'm sure all of us have the experience where your friend can't get the pictures of the pandas off of their laptop, and they ask you how to do it, and you say, "Well, did you hit Alt F4?" And they go, "Oh, wow, you're a computer genius," and you're like, "Yeah, not really, right?" or maybe I am, but that's not why I knew Alt F4, And I think that's kind of the thing here. I hear the mechanical engineers talking about cycloidal drives, which sounds like some Star Trek doublespeak,
Yeah,
or
right.
It's Captain, it's the cycloidal drive, or a Belleville washer or an Oldham coupler. And I'm thinking, oh, those guys are geniuses, and they probably think, yeah, that's just a thing, right? It's just what we do. So I really think it's interesting that the 3D printers have really opened that up for us. And you talked about his plastic getting soft in the heat, but the materials keep getting better and better. So even though I'm despairing of seeing a real practical metal printer in my lifetime that's going to sit in my shop, I can get metal parts made more cheaply than ever. That's been nice. But also, I think we're going to see engineering polymers get better and better. And so maybe at some point you don't care as much about the metal. And if you look at some of the polymers that are out there, he probably could have found something that would sustain that heat, rather. Maybe not, but at least it would have been a possibility. So.
And the other thing that was really cool about this to me is that he does just take these parts that he's kind of proven with the 3D printing and then say, oh, well, now I've got a 3D model for it. I'll just get these made on exactly the same specs, and boom, he's done. And that, I think, is actually really powerful and kind of a new opportunity for a lot of us to get custom machining done where we couldn't do it before. And no surprise, it's one of the Chinese board houses, the same ones that have kind of, by doing all that stuff really cheaply, have also kind of democratized the making of PCBs. They're trying to do it in the 3D printing space. They're trying to do it now in the machining space. It's really interesting. And, I think as this project shows, a college student can get a fancy custom motor design done and made out of metal. And, it ended up being a few $100. That's expensive, but that's nothing compared with what it would have cost before if he could even get a metal shop to take him seriously to do this part before. I think the ease of prototyping it plus the ease of just the accessibility of getting it made is going to make things change. I think that's really cool.
Well, and certainly like in my case where I'm not very mechanical, it's nothing for me to go, oh, I laid out a board or I built some, structure. And when I get it back, it's wrong. It's seriously wrong. I didn't realize this piece has to clear that piece. Oh, damn it. So being able to do that fast, cheap plastic prototype is a real game changer so that you don't say, okay, I spent, $15,000 on injection molding tools or dies or whatever. And then it's like, oh, wait, that hole should have been in a different place or whatever. So that's been a real game changer to me. I've always said, I really couldn't write without a word processor. If I just sat on my Selectric and banged it out, it would be so horrible. And it's the same way. I've laid out boards without a computer. And in fact, the first time I did that, my boss at the time said, "Who laid out this board?" And I said, "I did." And he said, "Don't do that ever again." And that was with the old tape on a drafting table. But with the computer, I can do it. It might take me 4 or 5 shots, to get where I want. But it's a game changer. The productivity side of it is another issue, probably too much to talk about here. But, is it good that engineers are spending time laying out boards? Well, is it good that executives are doing PowerPoint charts? And, I don't know. There's some debate about that. But certainly from a hobby standpoint, we've got power that would be undreamed of by anybody but the largest company engineers when I was a kid.
I would be remiss if I didn't mention that just last week, Dan Maloney wrote up a piece on electrical steel, the material at the heart of the grid. This is a kind of deep dive into electrical steel, the stuff you make, for instance, these data cores in this video, how it's made out of sheets and electrical steel, which has specific permeability properties. Anyway, want to know more about that? Go check out Dan Maloney's article linked in the webpage.
That was a great post, although I still want to see the Hackaday graphic novel Electrical Steel Robot Detective, right? I think that would be the...
Lovely.
Okay, my first pick for the week, Diode Gone Wild, actually took us down memory lane and brought us through a deep dive of how to use a 555 timer. It's a running joke that whenever we post something, we always get some comments of, well, I could have done that with a 555. My theme this week, in the old days, you didn't have the microcontrollers, so you did different things. Well, what's a 555? It's a constant current source that charges a capacitor in a straight line, a comparator, and a transistor switch. That's kind of it. But man, if you've got those blocks and can put them together, you can make lots and lots of different things. So you need an oscillator, you need something that goes once, you need all the things we used to have to remember. It's an astable multi, all those had specific meanings. I love that he kind of went through and just dug through it piece by piece. And one of the things that came up interesting, Dan wrote this up, talking to Dan, we were talking about how are 555s made today? And we don't know the answer to that, right? Are they still made in the same way that they were made 20 years, the chip's 40 or 50 years old. And, I did kind of dig around. I found somebody's, I don't know if it was their thesis or it was basically a school project where they redesigned and fabbed a 555. But of course, that's not commercially. That was just kind of a one-off. So we might see that in a future article from Dan, or maybe not. But I just think that's really interesting. And just as somebody who designs stuff and writes stuff, I just crave having something I did still being in common use in 50 years, right? I think that would be so awesome. So I just really thought that was a great video. I was glad to see it. And, sometimes if you can, in fact, do it with a 555. When we had our anniversary podcast a couple of weeks ago, we kind of talked about how the 555's more or less been usurped by the little tiny microcontrollers that cost 35 cents. But there's still some things you want to do analog. And if 555 will do it for you, why not?
I don't know how many of our people out there treat the 555 as an analog chip, how many of them treat it as a digital chip. I mean, it's kind of the in-between zone, right? It's kind of that chip that lets you make square waves if you need them, but it's also deeply analog underneath. And I think that's what's really pretty cool about it for me. And he gets into that here. And, like you said, it's a comparator and an op amp, and it charges and discharges the capacitor and resistor network you put on it, right? Like it's a building block, but it's just such a kind of versatile building block, I think, that a lot of people took to it.
It's the aluminum extrusion of electronics, right? You can build anything with aluminum extrusion.
Yeah, totally.
So. But it is sort of digital. I mean, the comparator's digital, but I think the charge-discharge is kind of analog.
It's full analog.
But certainly it doesn't have software, right? There's nowhere that you encode anything on the 555 unless you count putting a resistor across 2 pins, right?
Right.
So.
Yeah, it's certainly not programmable digital, right? Like it's not digital in that sense. Our talk of shame during that show when not a single one of us has used a 555 in the last decade. But yeah. Like you said, microcontrollers, what you going to do?
That's right. And then if you really need power, you went with the 556, right? Which was two
Two of them.
555s. Yay.
More 555s than anyone could need.
That's right. As Bill Gates famously said, right? Nobody needs more than two 555s. Oh, wait, I made that up. Sorry.
All right, well, my next hack is a gonzo feat of reverse engineering, mapping the Nintendo Switch PCB by micro soldering. And I have to say, the name checks out. What he's doing here is trying to figure out everything going on the Nintendo Switch's motherboard PCB. And because it's multi-layer and because a lot of the traces are just absolutely tiny, and he doesn't have access to an X-ray, he doesn't have access to, I guess, some insane flying probe machine. He does it by hand. And this means desoldering all the components. So he's just got the bare PCB and then taking a bunch of ultra high resolution images of it, stitching them all together, and then soldering meticulously by hand, like 2,000 contact points. Every exposed land where there was a component before, he solders a wire to it and then off to some machine. And I actually really want to see his test rig described a little better, that then says, are you connected to this wire? Are you connected to this wire? It's got like a 2,000 way switch and that then puts a high voltage on one pin and sees where it goes. And by correlating this with the images, he can completely reverse engineer every trace on the board, kind of quote automatically, although he had to solder all of these wires together. And you have to see this picture because it looks like a porcupine.
And that really looks like my dog's fur there in the picture. I don't know. He was actually that color. So we have a lot of things around my house that look like that. It's just they're not wires. So yeah.
I think what I like about this is just the most amazing brute force approach. Because if you think about it, a PCB is nothing more than connecting this point to this point and this point to this point, and sometimes one point to multiple points. But, who cares, right? It's just a bunch of connections between all these points. So if you're able to kind of label all the points and beep them out, imagine you had your multimeter and you were just like, is this one connected? Is this one connected? Is this one connected? But here he's doing this kind of automatically with a super insane, must be multiplexer switching device on the upside of it. Really, really fun to see. And he wins in the end. At the end, he has a net list, and it's probably the complete net list if he soldered every wire to every point. And he's also got an image of it, so he can then correlate the net list with the image and figure out, where this trace goes, where that trace goes. Absolutely insane. Took him 3 weeks of hand soldering.
I'm impressed it was only 3 weeks, to tell you the truth. I think you have to qualify that only 3 weeks, I think is the way
I think that's correct. And I don't know how you do this with a flying probe machine either, though, because if you imagine there are, say, 2,000 test points on this thing, and you have to check each test point in principle with every other test point, right? Like, that's a lot of probing to be doing. And even if you have one of those crazy spider machines with 7 or 8 flying probes that just go at insane speeds, the combinatorics of 2,000 wires is just absolutely mind-blowing. So maybe you do have to do it in this kind of massively parallel brute force approach. I don't know.
I couldn't help but think when I saw this. I mean, first of all, great respect. I mean, that's amazing. I can't make 200 solder joints without getting one or two of them wrong. So if you could do 30,000.
And labeling them all.
Yeah, I mean, you've got my salute right off the bat. However, I couldn't help but think one of two things is I wonder how much a bed of nails tester is on eBay. That was the first thing. And second of all, for this much work, you could have probably broken into a hospital and x-rayed the board in the middle of the night, right? Or found somebody with an industrial x-ray and say, please, I'll give you I'll give you something nice if you x-ray the board for me. I've done reverse engineering of integrated circuits. And of course, that's sort of the same problem, not quite, but we would never do so. We could never put 30,000 wires or even 2,000 wires down on a die. So you definitely take pictures, do probing, strip layers off, look at it again, x-ray, all that kind of stuff. But this is just mind-boggling. Just the fact that you could get it correct is, I think, an achievement. I always think that when I see the old computers that were wire wrapped, where there's a 19-inch rack and you open it up and it just looks like, 400 pounds of spaghetti in the back. And I'm thinking, who could do that? I would make, 50 mistakes out of every 1,000 wire wraps, and then you'd never find all those mistakes, which is probably why I don't build things like that, I guess. So.
What I like about it is that it shows that it's possible. It's one of those things that has to be possible to connect all the pins, but actually doing it and actually seeing it done, it's the first time I've ever seen it.
I will say too, that method would have a few minor problems on arbitrary circuit boards. Like I got a logic analyzer back from the 70s, and the shunt resistor to measure the current coming out of the power supply is just, 4 inches of PC board trace rotated around so it doesn't take 4 inches in space. So I don't think his method would necessarily tell you. I mean, it's easy to tell where it's connected, but the length of the line or a microstrip or something seems like you'd still have a little manual tweaking to do. But those things are usually pretty obvious too, right? So
My guess is he's not doing any analog with this, just from the size of the switching task, right? So like there's no way
Yeah.
he could possibly be.
I don't know. I would have said there's no way he could possibly do what he did. So I'm not sure I'm going to agree with that.
I hear ya.
I just wonder. I just wonder how much of that you would have to characterize, or like if there was controlled impedance on the board.
Oh yeah.
That doesn't probably pick that up. And if it's important, well, then you didn't quite reverse engineer it 100%. But even to get 90% on this is awesome. And I think for a lot of boards that doesn't really matter, and the traces don't really matter.
And if most of the wavy lines are going on the top face of the board or the bottom, he's got pictures of those. And so those he actually does know. But the ones in the middle, you're right, it's time to hire an X-ray machine.
Yeah. Well, my next pick was, I guess it's from Steam Pipe, because that's the name of the project. I'm sure there's somebody else behind it, but it sounds like a team. And it's called Steam Pipe. The title of the article was Steam Pipe All SQL All the Time, or if you prefer, All SQL All the Time. It's kind of interesting because SQL's been around for, decades. It's the normal way most people access databases. And we've talked about things like SQLite, which happens to be at the core of this before. But what's interesting is they've got 100 and some odd plugins, and I'm sure getting more all the time, where you can say, well, I would like to look at RSS feeds. And so now suddenly you can do queries on RSS feeds. Or if you use for software development, something like, say, GitHub is a good example. So you plug your GitHub credentials in a file, and suddenly you can do queries on your GitHub projects. So if you want to say, well, how many issues are there across all my projects, you can write a select statement that would tell you that. And of course, that also means anything that can manipulate SQL, or any kind of software that can make a call into SQL, you can use that. Now, you say, well, yeah, but GitHub provides an API, so that's easy. I just make up some JSON and I plug it in and I do the SOAP transfer and all. Yeah, but this is SQL. It's just easy. Everybody knows how to write it. There's all sorts of tools to debug it. Now, obviously, if you don't have a plugin for what you want, so for example, it would sure be nice to have a WordPress plugin. That would do a lot for us, right? But I haven't seen that, but it doesn't look like it'd be that hard to do. Somebody just needs to do it. And it's clear with 140 of them, there's all sorts of things you can get to. Is it a hack? Not exactly, but I think it enables a lot of hacks, right? When you can start grabbing data from different online sources this easily and then do things with them. So do you go get your weather with a SQL query on a Raspberry Pi and display it on your projected LED screen or something? Well, then that's something more like what we would want to do. So I think this is more of a tool to build some of the things we want to do. And after this post published, I had a couple of folks come up and say, we have something really similar to that that's also open source. So I don't know if we're going to dig into those very much, but this isn't the only game in town. Apparently, there's other things that do similar things. And of course, I'm sure everybody thinks theirs is the best way, and I don't really have an opinion about that. But this happened to be the one I saw first, and it was really fun to play with, and makes a big difference if you want to go grab stuff off the internet.
Yeah, I saw your example and I like it because it's like, select title, comma, link from RSS item, blah, 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 right? And so it's pretty obvious and intuitive, but that the variable that contains the title is called title, and the variable that contains, like the main link in the article is called link, must be defined somewhere in some API or something over, some list of the mappings of column names, essentially, of this SQL table to what they represent. And That's where it strikes me this gets hard again. As long as these names are really intuitive, everything works out great. But if, there's two titles, or if there's a link and another link or whatever, then you have to start giving them more complicated names. And then, then you're back at the stage where just going and fetching the JSON from GitHub's API is the right thing to do. Because what this kind of does is it makes an easier unified programming language for all of these many APIs. And I think that's awesome, as long as they do something kind of predictable. If I had to look up what the titles of Hackaday articles were called in this thing, it wouldn't be nearly as intuitive as it is. So I think there's some clever forethought in creating the plugins that feed into the database that's necessary up front.
No, I agree with you. And I think that's two issues, actually. One is you're depending on the plugin author to do a good job. So if you had two titles, maybe they should have been in two different tables, because it's probably not two titles. And I think the ones they have are pretty good, pretty well done. If you look in the documentation and you look at the plugins, there's a tab that says tables, and it'll say and I'm just making this up, I don't know if this is right. If you said GitHub and you click tables, it'll say, oh, there's 14 tables. And one of the tables is, GitHub issues or something. And then GitHub issues, when you click on that, it'll say, well, it has a title, it has a due date, it has an assignee. But if you went to, say, pull requests, well, that might also have a title, but that would be a different table. And I'm making all those things up. I think the other key is it is open source. So if you don't like it, you could, write your own plugin. And certainly I think you could have multiple plugins for one thing. And I think that would be supportable. I think what really is lacking here, though, and it's not SteamPipe or anybody else's fault, is the real power to SQL is being able to do joins. And if you didn't have coordinated effort between different sources, then that becomes more of a problem. So, I'm just going to make up an example. If I've got an API that gives me the weather based on latitude and longitude, and then I also have news stories, but it's based on zip code, I can't really do a join on that and get a single view of both of those items in any real way. I'm sure there's some hacky way to do it and say, oh, well, this zip code's this lat long within this range or whatever. But that's not, now we're back to, like you say, well, why didn't I just make API calls and do the work? If you had if this really caught on and people started saying, okay, here's a standard set of things that you want to put in a way that they'd be joinable, I think that would add an extra layer of beauty to this that probably doesn't exist today.
My next hack is an analog circuit deep dive from Alan Wolke, W2AEW. No inductors needed for this simple, clean twin T oscillator. And I love this one partly because I love the twin T filter that's at its root. Let's see, for you analog folks out there, it's a notch filter, which means it kind of cuts out a particular frequency out of some sound you've got. And so, for instance, if you have a voltage signal you want to measure and it's contaminated by your mains frequency interference, that's awesome easy to remove. You just make a notch filter centered at 50 hertz in Europe, 60 hertz in the States, and boom, your data is looking clean again. Love twin T filters. What does this have to do with a sine wave oscillator? You take this filter, basically, you take this notch filter and you put it in the feedback loop of an op amp, and the op amp tries as hard as it can to drive stuff through, and then it gets notched out at exactly the frequency you want, and the op amp then makes that frequency for you, and as a fairly pure sine wave. Alan talks about all of the tricks to tune up a twin T filter here. It's a simple circuit. It's got two resistors in a row with a capacitor to ground in the middle. That's one of the T's. And the other side is two capacitors in a row with a resistor to ground. That's the other T. And that makes kind of a low pass and a high pass that join together to give you this notch. Those components all have to be fairly well matched to each other. And he does in this video my favorite trick, which is where you need one value to be half of the other or double the other. You just use two of them in parallel or series, respectively. And as long as your component tolerances are pretty good, that most of the time does the matching for you good enough. If you need to tune the exact frequency in, yeah, you need to do some variability with that single resistor. And he proposes a neat rule of thumb here that I think sounds about right, which is if you ever have a component that you need to adjust, you can just like reduce the resistance by 5% and then throw in a variable resistor that's about 10% of that value. So, you kind of get plus or minus 5% leeway tunability on either side of it. That's a statement that obviously comes out of his old experience with tuning up tweaky little analog circuits. So I thought that was a little tidbit to put in my tidbit jar. Where do I keep all these funny nuggets of knowledge? I think
Your tidbit database, which you access with SQL.
in my head.
Well, I always look forward to Alan's videos, not just because he's a ham, but man, he's got some stuff going on, and this one was no exception. I think it's really great. He's clearly got such a deep understanding of the analog circuitry. And, one of the things that I thought was funny is the come on to this is, hey, you don't need any inductors. The hidden part to that is that of all the components we use, inductors are frequently the worst ones, right? They're always bad characteristics. So nothing is as good as we think it is, right? Even the schematic wires have some resistance, but usually not enough that we care. Resistors aren't perfect, and as you say, maybe we need to match them, but you can not pay a whole lot of money and get really good resistors. Even capacitors, you have to take a little more care, but generally a high quality capacitor. But getting a really high quality inductor without a lot of bad parasitic effects on it is almost impossible, very expensive. And that's why you see things like gyrators, gyrators, an op amp that phase flips a capacitor so it looks like an inductor.
Anyway, the Twin T is a super fun circuit, not hard to understand, super useful, and it actually is. These kind of Twin T oscillators are the sound of old analog drum machines. And I ripped that off in a Logic Noise series I did a million years ago, back in 2015. I'll link that in here because the circuit in there makes a really nice bass drum sound. And it's kind of reminiscent of the one in the Roland TR-808, which is in like every rap song you like.
I didn't know that.
Yeah, it's done with a Twin T. They do it with a Twin T and a transistor because it's like absolutely as cheap as possible. I do it with a Twin T and an op amp, but potato.
Interesting.
Goes whoom.
I thought all that had gone digital.
It has, but it's gone digital, but then it's gone analog back again. All the cool kids know where it's at.
Because that was always the big project in the magazines before the microprocessor was music synthesis stuff because it was interesting and you could actually do it.
That was my gateway drug. Yeah, totally.
Yeah. A lot of people I think had that experience. My last hack today is the Pi Pico Enhances Radio Shack computer kit, which is Don Wilcher taking a science fair microcomputer trainer. And so I just love all that old hardware. I never actually had one of these as a kid. I think this was a little bit past me being a kid. Back when I was a kid, the Radio Shack computers were really just giant switch arrays that you built up switches. And so 2 switches in series were an AND gate and 2 switches in parallel were an OR gate. But this one actually had a little microcontroller in it, TMS 1100, which I think Jenny did a good post on that a while back about how that's arguably the first microcontroller, 4 bits and, more industrial kind of applications. But somehow they wound up in a Radio Shack trainer. And I think what was interesting, I mean, he did some stuff with made it to a clock and drove it into the stuff. But what I thought was more interesting than just the actual application was the idea that while you might buy a kid back in the 80s or whenever this was current, this giant colorful cardboard chassis with a bunch of switches and lights and a display on it and make them go, oh, that's interesting. Now you could back that up with a Raspberry Pi Pico, which has enormous amounts of flash memory, 64K RAM, 2 processors running at, I can remember in the 80s, that would have been a supercomputer, much less hooked up to a trainer to train kids. But I think that's interesting because I think sometimes we underserve that market, right? If you're 11 years old and I show you a Raspberry Pi Pico, it probably doesn't look that interesting unless you're just really cut out for it at heart. Whereas this thing's colorful and it's accessible looking. And of course, I'm sure that you could come up with a lot of projects to do with all these pieces. It's got the little spring connectors. So you pull the spring back, stick the wire into the coils of the spring and let go. So you're not soldering. You don't have little surface mount parts to worry about. And, you mentioned gateway drug. I mean, I think something like this could be, whether it's a hack of an old box or somebody would produce something more modern like this, I think it could be a real gateway to young people getting their feet wet into something like that.
If it were smaller, it would be like a good badge for a Hackaday conference.
Uh-oh. Uh-oh.
The 301 badge. Ooh.
Oh, that's
Ooh.
good. I like that.
Where do we get those springs, though?
They're springs. I think you get them from the spring store.
You think
I
they're
don't
just
know.
regular springs? I mean, maybe they are. What do I know? All right, my quick hacks start off with KISS Analog Spectrum Analyzer Buyer's Guide. This is really neat because you may use the FFT function on your scope to give you kind of a quick and dirty spectrum analyzer like function. But here he shows you what more you get by getting a real dedicated spectrum analyzer. And that basically amounts to bit depth and resolution and bandwidth. But watch the video if you're interested in looking at spec ans. Next up, Mitsela LED matrix earrings show off SMD skills. And just when you think he can't make anything smaller, he does. You should really go check this video out. It is fantastic. His last one that we featured had a bar earring with 8 or 9. This one is a matrix in the size of what? A normal Electret microphone.
Like a mercury cell? I don't know.
Next up, Pascal Martinet, stereo photography with smartphones made better with syncing. This one is really hard problem. How do you take two exactly similar photos from a different location at exactly the same time? He ends up making a little, it's really just a Y with a switch in it that plugs in and tells both phones to fire off at the same time. Of course, they both have autofocus and their own ideas about exposure, and getting all the finer details right requires some software, but this little simple hardware hack lets him at least press the button on both phones at the same time. And last up, HackMakeMod, a classroom-ready potentiometer from Pencil and 3D prints. It's a really cute demo of how a potentiometer works, made by rubbing graphite on a piece of paper and using that as the track that the wiper goes on. The rest of it is just a nice 3D print that clips this paper in place, clips the wires to it. No soldering needed. Everything is easily assemblable, disassemblable, and it shows anyone who's interested how a potentiometer works on the inside. Totally, totally classroom appropriate, but makes me want to make one just because it looks like a lot of fun.
And if you add some tape, maybe you could get graphene out of it, right? So there you go.
That trick with clips and wires to make circuits is actually really much more broadly applicable, I think.
Okay, my quick hacks this week. Oliver Child has sonolithography with the Raspberry Pi Pico. So, that's another Star Trek sounding techno talk is sonolithography. We'll use sonolithography, Captain. Essentially, it's an array of ultrasonic transducers under control of a Raspberry Pi Pico and a GUI interface so you can kind of mix everything together and make patterns. So if you were the kind of person that liked to stare at your screen and do Mandelbrot's, this would appeal to you. Lewin wrote it up, Lewin Day, and he says it could be a useful tool for studying the interaction of ultrasonic waves. And I'm thinking, yeah, who are you kidding? It's just cool looking. And I'm with, like you said earlier, it's who are we kidding? Next up, Cyclo Garage has that canned air is unexpectedly supersonic. And not only was this an interesting post, apparently the canned air that you have when the air leaves the nozzle, it's supersonic, and you can tell that by looking at the, what do they call it, the mock diamonds.
Yeah.
And there's actually pictures of that. But the comment section on this was really priceless because there were people who clearly knew a lot about this, and they were talking about how well the speed, because of the pressure of the gas and its difluoroethane and the speed of sound in difluoroethane. And so it's an educational post to read, but don't miss the comments as well. And last, but certainly not least, CPS Drone, who has, it's actually a group that has been making a lot of submersible 3D prints. They decided to try to figure out how to make their prints a little more waterproof at depth. And they made a little test rig where they'd pressurize it up and get the water into it. And they used a chemical, I don't know if I'm pronouncing it right, I think it's dictol, which apparently is very smelly, but it was waterproofing the interior and actually worked pretty well. I was surprised. Again, in the comments, people say, well, there's other things that work well too. So read the comments. I thought what was most interesting, though, they had done some fairly interesting tests about how much water had come in by weighing the submarines and emptying them out of water and then weighing them again. And apparently, a significant amount of the water was actually coming in to the interstitials between the layers. And, I don't know exactly what the physics of it are, but it wasn't just water was getting through the wall and into the interior. There was a substantial amount of water embedded in the wall. So like they, just for a test, printed a solid submarine, and even it wound up weighing more after being in the water because the water was pushing into the print, even though the print wasn't hollow. So there's a lot of different things to think about. It's kind of fun to watch them blow up submarines in a pressure tank too. But, again, who are we kidding? But if you ever needed to make a waterproof print, they had a lot of interesting data to probably save you some time of having to figure it out yourself.
All right, that brings us to our Can't Miss articles. These are fantastic long-form pieces written by our Hackaday writing staff. This week I'm picking Maya Pasha's Car Driving Simulators for Students, or When Simulators Make Sense. This is a neat thought piece. Why don't we train new drivers in simulated car driving? Because, for instance, people who fly spaceships, people who fly Formula One race cars for a living, commercial airplane pilots, these people all train on simulators and kind of accredited simulators before they do it in the real world, because the consequences of doing it wrong are very severe. Why aren't we doing this with 16-year-olds on the road? Because they actually end up in a lot of accidents, and Maya points out it's the motor vehicle crashes is the leading cause of death among U.S. teenagers. So why aren't we doing this in a simulator? And I learned to fly quadcopters a couple years ago now, and one of the first pieces of advice everyone gives you is do it in simulator first, do it in simulator first. And I'm like, nah, I'll just go wing it, right? And I'm winging it for a day, and I'm crash, and I broke something. And then I'm like, okay, well, it's broken now. I got to fix it. While I'm waiting for the epoxy to cure, I'll get one of these simulators that everybody's talking about. And I did it, and I'll be damned. You crash the thing until you figure out how to not crash it, and then you can fly it on the real thing. And that transition, at least for quadcopter simulators, was superb for me. And so this is my one data point that proves absolutely nothing. But this is why kids should learn to drive in simulators, right? Well, it's been thought of before, and in fact, back in the 50s, and she has a neat retro-tectacular kind of video about the Drivo trainer, which is the best name ever, and also brings up some modern studies where they try to do this, and it doesn't look like it's working. Why is kind of an open question. And I think that's where the article ends is, this seems like a really good idea. It seems like a no-brainer. Airline pilots are trained in simulators. Why aren't 16-year-old young drivers trained in simulators? And the answer is there's something else going on.
Yeah, I don't really understand this one either. Truck drivers, commercial drivers are frequently trained on a simulator. And I saw a quote from somebody at Schneider National Trucking that said I don't know where they got the statistic. You know what they say, 97% of all statistics are made up on the spot. But it says 1 hour of simulator training is 4 hours behind the wheel training. Embarrassingly, I had to take a motorcycle license test a few years ago because I've never had a motorcycle license in Texas, and so I had to take it again. And one of the things they do is they make you, because you got to do the training to do the test, they make you approach some pylon and just stop within very short distance so you can kind of get the feel of the brakes and show that you can do that. Well, what if you can't do that? Then you're going to whack into the pylons, maybe get thrown off the bike. That would be much better. And you could do really worse things even on the simulator, right? What do you do when this guy swipes 6 centimeters away from you? Well, you can't do that in real life because it's just too dangerous. It would be like a live fire exercise. But I can do all sorts of nasty things to people in simulation. Now, is it exactly the same? No, but it's probably better than just saying, oh, well, if something really bad happens, you'll probably figure it out. Let's at least talk about, do you pump the brakes? Well, not if you have ABS on a car, for example. certainly NASA's full of simulators, and there's a lot of famous scenes of that in the movies where they just keep throwing one bad thing after the next at them. Or even the Star Trek movies, right? They see it, they're simulated on the bridge and bad things keep happening. So I'm not sure what the reason is. Part of it is just inertia, I think, and part of it is probably funding. But especially now that the technology is so much better and so much cheaper. And I'm thinking, man, if you did the right software and a VR headset, all these people trying to push into the VR space, this would be a ready-made public service market that would get a lot of people used to that technology.
Yeah, and the car driving simulators are out there already. I mean, there's amazingly accurate race car simulators and others out there. And someone said this in the comments that they had to do an emergency maneuver and the car behaved exactly as it did in this racing sim that they were used to playing. And I'm like, yeah, exactly. A friend of mine learned to drift in racing sims and then started doing this in real cars on the track, but it carried over straight away and he still lives today. So, something worked. So I think it is really interesting. My secret fear, having been a 16-year-old myself, is that the problem with 16-year-olds is more of attention and taking the seriousness of the situation seriously enough. And so, that's where a professional truck driver in a simulator learns 4 hours of behind the road time, but then a kid who's grown up playing Grand Theft Auto, I don't know how much extra they're going to learn from more video game like simulators versus what they really need, which is probably just taking the real situation of actually being in a 1,500-pound death machine seriously enough, right?
Yeah, it's kind of funny. We did a post a while back. My son actually built one of these. He loves to do the race car simulation. And so he's got the fans on it so that the faster you go, the more you feel wind on you. It's that much realism. But he did the thing a while back where he went and they put you in a car with a real driver. Not that he's not a real driver, but you know what I mean. Because he might listen. He'll probably never listen to this, so I can say what I want, I guess. But an experienced race car driver. And it was some hot race car, and he drove it around the track, 5 or 10 times. And there's all sorts of rules. You can only pass if they let you pass, and there's a limit to how fast you could go. But one of the things that he's got a YouTube video they made of that, and the guy said, "Oh, you're doing really well," and he says, "Well, I spend a lot of time." In racing sims, and he said, "Yeah, I figured you might because you're doing better than you would normally do if you just walked it off the street." But and certainly, he probably did better than I would have done for sure. And I'm sure that's because he spent a lot of time sitting behind a fake BMW wheel in front of a couple of fans powered by an Arduino. Well, in a first, I think this week I picked one of my own articles, which I don't normally do, so I apologize. This week we did a couple of interesting Linux foos, but I wanted to pick the forward to the past. I guess I'm on a nostalgic kick this week. We're talking about the Radio Shack parts and all the different pieces. What I thought was interesting about this is it's for an open source product called Run CPM. And as you might expect, that lets you emulate CPM under Linux. And you say, well, who cares? That's been done to death. SimH and Z80Pack and all that stuff is out there. But Run CPM had a couple of things that really caught my attention. It's really more like wine for CPM than it is a traditional emulator in that it lets you access more or less the Linux file system and with some caveats, but also it will run on an enormous number of computers. So if you've got Windows, it'll work there, Mac, it'll work, but it'll also run on an Arduino, a Teensy, an ESP32, an STM32, and they've got experimental support for like one of the other ARM processors and Cyclone 2 FPGAs. So that's kind of interesting too, because if you said, well, I'd like to do some development, but I also want to go make a fake Altair and put an ESP32 in it, well, it's the same code base. So if you fix a problem somewhere, it's going to be fixed everywhere, as opposed to, well, I fixed this problem in my Linux simulator. Is it really the same problem in oh, no, it's a different problem in the other simulator. So I thought that was interesting. The biggest thing was, though, is the file system is just, there's a subdirectory called A, that's disk A. There's a subdirectory called B, that's disk B. If you've ever tried to run CPM stuff on any kind of emulator before, you have to say, well, I'm going to make a disk image, and then I got to copy stuff into the disk image, and then if I want to get stuff back out, I got to copy it out of the disk image, or I've got to X modem it after I log in and out. None of those are particularly handy. I guess the real thing is you might say, well, why do I even care? Well, first of all, it's Hackaday. Why does anybody care about this stuff? It's retro computing. It's the past. Everybody likes to think about the Altair and those similar computers running CPM. But even beyond that, I mean, there's a pretty thriving community of people writing 8080 and Z80 software for a variety of reasons. This would be a pretty good environment to debug that and run that. And so because it's got a shared file system, even if I want to go open that source code up with Emacs or, okay, Elliot, I'll go with VI for you, or Visual Studio Code or whatever I want, I could do that because it's just a file on my hard drive. It's not buried down in some arcane fake CPM 180K diskette. So I could sit there and do my editing in VI, save it, go over to my console, compile it, or, assemble it with the CPM assembler, run it, try it, and it would be workable. The other thing is just, I think the access to this sort of thing, if you really want to learn stuff down at the base level, going where people have been before isn't really a bad idea. And while some of this stuff will never help you ever in a direct sort of way, I think having that kind of understanding of the past sometimes informs what you either are doing in the future or what you'd like to do in the future. Even if it's in a negative way. Well, I don't want to do that, right? That was too hard. So anyway, I thought it was really cool. I haven't tried it on any of the embedded platforms, but they tell me, like, if you're on the Arduino platform, it actually has a way that you can access the I/O ports on the Arduino natively. So you could write a little CPM program that, actually turned on a sprinkler and, watched a water level or a temperature or whatever. So that would actually make it kind of interesting too if you were really wanting some kind of retro practical computer and not just a showpiece.
I'm always on the lookout for kind of running environments on microcontrollers. I've really enjoyed using MicroPython because, it gives you a live terminal. I used to be a super fourth nerd on microcontrollers for exactly the same reason. You've got a shell. You can type, turn this pin on, and boom, pin goes on now. This just lets you prototype stuff so much easier. Is that part of what's going on with CPM? I am totally naive. Imagine that I have never, ever, ever even seen a command prompt in CPM, because that's true. Is CPM that sort of thing? I always thought it was kind of more of an operating system sort of thing than a directly accessible shell, or what do we got here?
Well, it is an operating system and it is a shell because keep in mind, it's not much of an operating system. I think to answer your question, we agree on Forth. Forth was great. I always liked Forth. There's some really great historical Forth implementations for the Z80, and there's been huge amounts of software written for that. Some of it was very mature. There's a lot of other things that you can run under CPM that are of historical interest, like the old Microsoft Basic. I hate to say it, but every once in a while, I like to fire up WordStar. And see, this is convenient because I don't want to move my file over into the fake drive, start WordStar, edit it, and then have to move my file back out. Well, I don't have to with this. My file's there. I just edit it right in place and I pull it out when I want. Now, you say, why do you write in WordStar? Well, I don't know, just to keep my finger practice up because I've written millions of lines of various things in WordStar. I'm trying to remember. It seems like George R.R. Martin, he either still uses a DOS version of Word or WordStar. I can't remember which, but apparently all of his books are written in some DOS or CPM type word processor. So I think everybody's got their own reasons. I'm not saying, everybody should run out and do this and put it on Arduino and it's going to make your life better. But I am saying if you wanted to learn more about how to do Z80 development, this is the way we did it for a long time. And there's still a lot of really good stuff out there for it. This lets you access it without having to buy $1,000, well, more than $10,000 piece of hardware or some of the clones or build a new Altair or whatever. There's still a lot of embedded stuff, by the way, that has some form of Z80 in it, right? Not necessarily a Z80, but there's a bunch of Z80 type things and CMOS and all that still find their way in lots of little weird places. So kind of like the 8051, it might not be your first choice, but there's some advantages to using the 8051 just by its wealth of resources, and sometimes you don't have a choice because that's what's there. So maybe we'll get some comments on why you use CPM or why you use Z80 today, right?
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. The links you will find over at hackaday.com/podcast, and the tips you will write us, send them to tips@hackaday.com. And until next week,
keep those hacks coming. Is that going to be the name of your sausage stand at the event, is the best and the worst of it? Boo.
Hey, boo.
That's really bad. That goes in the after the theme music reel there. That's,
that may be your worst joke yet.
Worst joke, yes, absolutely.
Thank you. We're done here. Oh, I guess his is the stator. Crap, I just said rotor every time, and it's the stator in this one. They're backwards motors. Stator, it's the stator. These runners are outrunner motors. That's a wrap.